Now let's take a look at this. We know transformations, so which we could have not done with that one. I cannot use transformation on that because the square is not completed. But on this one I can. So this is x squared. Where do I go now? How many? 3 to your right. And then, what is the vertex of this parabola?
2.
Careful. I need 2 coordinates, right? Exactly. So therefore, can you tell me what this represents? H comma K. Indeed, that is the vertex. So if the square is completed, no calculations are required for the vertex. We determine the point right away. That's the only difference from this and this. The only difference. But this one, no calculations for the vertex. I just have to read it. There is nothing else different. Okay. So I start with the same things. The domain. What is the domain of this function? Very good. Number 2, the shape. I already know. I already have the graph in my head. I already pictured it. Minimum or maximum? Minimum. Very good. Number 3, the vertex. 3 comma 2. Very good. Number 4, X-intercepts. Picture the graph and say yes or no. Right? So this was x squared. This is x minus 3 squared, and we go up 2. It does not touch the x-axis. So what is the discriminant in this case, if I were to find it? What type of number? Definitely, if it's positive, it will cross the x-axis. If it's 0, it will touch the x-axis, but it's way above, so I cannot find any solutions. So the discriminant must be a negative number. I can't take the square root from it, right? Okay, very good, none. So number 5, Y-intercept. How do I find the Y-intercept? Now the Y-intercept, I have to be careful. It was much easier here, 0, 0, negative 3. So I have to be careful now. So let's do this together. So I have to find f of 0. How much is 0 minus 3? Negative 3. How much is negative 3 squared? How much is 9 plus 2? That's it. So I need a little bit of a calculation for the y-intercept, but not for the vertex. So what is the y-intercept here? Very good. So 6, 7, and 8, we already know they're just words. The axis of symmetry. Perfect. Does it have a min or a max? Very good. So the mean value is awesome. And of course, I'm going to ask you about the range, and you can say we haven't even graphed it, but you already know the graph. 2 to infinity. That's it. We can't find anything else about this. This is completely exhausted. So we start with a vertex. We continue with the axis of symmetry just to try to keep it. As you see, I'm not very successful at keeping them perfect. Both sides symmetric. So that's all I have, 3, 2, and I have 0, 11. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to create a point, 3 units on the other side. And as you can see, it's not perfect already. But I need a point on the other side to graph it. Of course, I missed it. It's not perfect, but I created a point on the same height, 3 units on this side and 3 units on this side. So this is f of x, which is x minus 3 squared plus 2. And with this, I would like to look at some word problems and see applications of the quadratic function. Any questions about graphing these functions? Yes, please. Jade?
What do you mean by this when you're asking for the discriminant? What do you mean by that?
Okay, so a few minutes ago we looked at these situations. So for a min or a max, it doesn't matter. So if this is a min, a max will, if this is a max, a min will look like this.
So they basically like the opposite?
No, I'm saying if the quadratic function does not touch the x-axis, the quantity under the square root of the quadratic formula must be negative. If it does not touch the x-axis, this quantity must be negative. If it touches in one point, although there are 2 points in there, but two solutions, but the same ones. If it touches, then the discriminant, this quantity must be 0. This is the discriminant. This is what we call discriminant, not the square root, just the quantity under the square root. So this must be 0. And if the quadratic function crosses the x-axis, these two solutions exist, which means this must be a positive number, this whole thing a positive number. So I can get two distinct solutions. So if it's 0, I only get the vertex. If it's negative, I don't get anything. The function does not touch the x-axis. And if it's this whole thing is positive, then it's this situation or that situation.
Okay, I see.
Better? Okay, very good. Okay, so let's look at a couple of word problems with applications of quadratic functions. On page 361, let's start with problem 60. A ball is thrown upward and outward from a height of 6 feet. So we can imagine, we can picture this. So this is the height of 6 feet. And we throw something, a ball, let's say. At some point in time, it will reach a maximum height and then eventually hit the ground. So we're given the height of the ball. So this is the function f of t in feet. Oh, it's f of x, I'm sorry. That is negative 0.8x squared plus 3.2x plus 6. X is the ball's horizontal distance. So this is x, horizontal distance. And y, or f of x, is the height. Okay. So the first question is, what is the maximum height of the ball and how far from where it was thrown does this occur? Well, obviously in my drawing, this is how far the maximum happens, and this is what? The actual maximum. Indeed. Height. Yes, that's correct. It's the maximum height. Perfect. Thank you. Okay, so let's look at this function and say this function is quadratic. How do I find its maximum? Or what point am I after? Or what do I have to find? First of all, does it have a maximum? How do I know? Because the leading coefficient is negative. Remember, x squared has a positive leading coefficient. Negative x squared has a negative leading coefficient. So does it have a maximum? Yes, because the leading coefficient is negative. Perfect. How do I determine the maximum? What do I need to calculate?
The y value of the vertex.
Yes. How do I determine, in other words, thank you, how do I determine the y value of the vertex? Not before I find
The x value.
the x value of the vertex. How do I find the x value of the vertex? How did we find the x-coordinate of the vertex? We did something a few minutes ago. It cannot be the x and y-intercept, or the x or y-intercepts. Perfect. Negative b, 3.2. 2 times a, negative 1.6. Answer. And measurement unit. 2 feet. So this is the distance. Oops, I missed it. So right here, 2 feet. Now how do I find the maximum height? Plug it in. So I have f of 2, which is negative 0.8 times 4, plus 3.2 times 2, and plus 6. This is negative 3.2. This is 6.4, and this is 6. So when I subtract 3.2 from 6.4, I get 3.2 plus 6 is 9.2, measurement unit. Maximum height, feet. So the maximum height here is 9.2 feet. So when I throw a ball out, up and out, it reaches a height of 9.2 feet. Eventually will hit the ground, but the distance from where I stand and where the maximum is 2 feet. Part B. How far does the ball travel horizontally before hitting the ground? So we want to determine this in part B. What does this mean? Oh, I'm sorry, this is 9.2. So what am I asked to find now? Of course. Very good. How do I find the x-intercepts? Say it again. We only found this point. Sorry, Carl, just 1 second. We only found this point. Exactly. Set y equal to 0 or the function equal to 0. Negative 0.8 x squared plus 3.2 x plus 6 set equal to 0. Awesome. And yes, I know I sound like a broken record. What type of equation is it? Quadratic. Good. So what do you think I'm going to do? I know you know me a little bit by now. I'm going to make it easier by multiply by negative 1. I refuse to solve a quadratic equation with a negative leading coefficient, but that's me. The reason why I refuse to do it is because I may forget to write the denominator in the quadratic formula as a negative number. So I know some of my weaknesses, not all. So I may forget. That's why I refuse. I say, okay, let me not forget, multiply both sides by negative 1. So now I will have to use the quadratic formula. Negative b, which is awesome, plus or minus the square root of 3.2 squared. Remember that quantity must be positive no matter what. Minus 4 times 0.8 times negative 6. Instead of putting out so many parentheses, I'm going to change this into positive over 2 times a, which is 1.6. You can use nested parentheses in here, but why? I just have 2 negatives and the sign changes to positive. It's up to you. So here's what I would like to do next. I would like to put all this in the graphing calculator. So parentheses, let me emphasize this very important thing. If you want to use the graphing calculator and not have to approximate or calculate piece by piece, you should put everything at once, but do not forget parentheses around the whole thing at the top and parentheses under the square root. So let's do that. So left parenthesis 3.2 plus the square root in parentheses 3.2 squared plus 4 times 0.8 times 6, close the parenthesis, go completely outside of the square root, close another parenthesis, and divide by 1.6. $5.39. Now, if I want to determine the other one, which I expect it to be negative, I override the plus. And it's negative. So what I need is 5.39. So x equals 5.39 feet. X equals negative 1.39 feet is not acceptable. So this is the horizontal distance, maximum horizontal distance, 5.39. 5.39. From this point till this point. 5.39 feet. So this was not really possible without us understanding how the quadratic function works, what the vertex means, and the x and y-intercepts, and so on and so forth. Any questions? Any questions? Can we look at another problem? Okay, so let's take a look. 61. Among all pairs of numbers whose sum is 16, pairs of numbers whose sum is 16. Find the pair whose product is as large as possible. Product max or maximum product. What is the maximum product? Okay. So we are thinking of pairs of numbers whose sum is 16. Can you give me an equation, but do not give me numbers? Do not say 10 and 6. But give me an equation with 2 unknowns, one is x and one is y, whose sum is 16. How do I write that? Very good. Now give me the product of these two numbers that are unknown. How do I create the product of these two numbers? What does it equal to? If it says product. XY, very good. Perfect. So let's see again what we are told. We are talking about pairs of numbers whose sum is 16, done. We are asked to determine the product, the maximum product. I have an expression for the product. However, I'm running into a difficulty because I have this variable and this variable. I have to eliminate one of the two. I don't know how to deal with functions with two variables. But that's the reason why I'm given this. Let's suppose we want to eliminate y. I will solve this equation for y. What do I get? Very good. Negative x plus 16. I will replace it in this formula. And now I will say, oh, now the product is only a function of x. So I copy x, and instead of y, I write, very good, awesome. Now I distribute negative x squared plus 16x, and I say, oh, okay. So I found an expression or a function for the product. What type of function is it? Quadratic it is. Does it have a maximum? Always remember, everything has to be in descending order. This must be like a second nature so you don't identify incorrectly. So is this a function, a quadratic function with a maximum or not? Yes, because the leading coefficient is awesome. So now I'm asking myself, fine, it's quadratic, it has a maximum. How do I determine the maximum? What do I have to find in order to get the maximum? I have to find the vertex. There is nothing else that will give us the maximum of a quadratic function but the vertex itself. Great. Now I have to think, how do I find the x-coordinate? Because I can't find the maximum product if I don't find the x-coordinate first. How do we find the x-coordinate? As you see, it's the same theme. Say it again. That will be for the x-intercepts. For the vertex, that will be for the y-intercept. I know it's late and I know it's a lot. Yes. Negative b over 2a. Just remember, the vertex has nothing to do with the x-axis unless it's on the x-axis, right? And nothing to do with the y-axis. Okay, so negative b over 2a. Negative. What is b? 16 divided by 2a. So the answer is 8. So if x is 8, I'm not talking about the product yet. If x is 8, can anyone identify the other number? Good. And since this is the product of these two, what is the product?
64.
That's it. And you can say, wait a minute, how did you get 64? And I'm going to say, I plugged in 8 in here. But it was much easier to determine the other number and just multiply them because this function is this function. That's how we determine it, by multiplying x and y. So here's the final answer. The maximum product of two numbers that, this is t, that add up to thank you, is
64.
awesome. Full stop. The numbers are x equals and y equals. That's a good point. Be careful, because this is p of 8 and this is the other number in the problem. But you're right, it could be confusing. This is not the y coordinate of the vertex, but this is the y that we denoted the second number by. That's why, in order not to get confused, I said, okay, let me find the other number so that this must be the product. Or if you replace x in here by 8, you will get 64. So x equals 8 and y equals 8. Any questions? Yes, please. Yes, the previous one?
Yeah.
Yes, let's go back.
Yeah.
The 5.39?
Yeah.
You forgot parentheses somewhere.
I did that was like everything.
You forgot parentheses in front of 3.2.
Oh,
So
you
if
just did that
you don't put parentheses, look at the parentheses up there. If you don't put parentheses around everything you have at the top, the calculator will do something else.
Okay.
So you can insert it, you don't have to delete anything. So go to the left and put second and insert. All the way, second and insert. And put a left parenthesis. And then go all the way to the end. And put a right parenthesis before division. Yes, you already have it. Okay, you have it. Oh, you put another parenthesis in here. Yeah. So everything here is fine, but you added this parenthesis.
Oh, okay.
Let's start from the beginning. So it was 3.2 plus the square root of parenthesis inside parenthesis. 3.2 squared, and then plus 4 times, what was it?
Oh, you're not supposed to put
Six.
parentheses around 3.2?
There was no need.
Okay.
There is no need. That's okay. And times 0.6, close the parenthesis, go completely outside, and then divide by 1.6. And you have to get the 5.3.
Okay.
Did you get the same thing?
Don't have the same problems.
Okay.
I've tried all different combinations of parentheses.
Yeah, because you forgot parenthesis, let me see what you put under the square root. Okay, you probably, your calculator doesn't need that, I put parentheses all over the place. But you forgot to put the parenthesis,
I'll do that up here.
no.
So you put the parentheses on the outside. of those.
You have to, yes.
Okay.
Yes, one more time, so let's talk about this. So when you put everything at once in the calculator, you have to have parentheses around the numerator, and you have to have, your calculator is way more sophisticated than mine. So I do put parentheses under the square root just to make sure I don't know what the calculator is doing, and I put parentheses around the numerator. And if the denominator has more than one term, then I will put parentheses around that as well. And you will see in the next section, at the end of this chapter, when we graph rational functions, if we don't put enough parentheses, we're not going to graph what we want to. Is that better?
Yes.
Okay. Other questions here? Very good. Other questions? Is this okay? So this is the trick. Parentheses and parentheses. Yes, you have newer versions of this calculator. I have an old one. So I put parentheses around the quantity under the square root. I put parentheses, I have to put, this is mandatory. Parentheses around the numerator, and again, if I have more than one term, I also put parentheses in the denominator. So you will see at the end of this chapter, we are going to look at functions that are way more sophisticated, I would say. For example, x plus 1 divided by x minus 2. We're going to talk about a lot about this function. So when we put in the graphing calculator, if we don't put parentheses around the top and parentheses around the bottom, we are not going to graph it.
Okay.
When we get to that stage in which we check, we're going to graph it by hand, but then we're going to check with the graphing calculator.
Okay.
So very important to remember that. I know you gave me 6 minutes. Since I promised that I will not do anything new in those 6 minutes, I'm just going to solve one more problem with you, and I would like you to choose. You want something similar to what we just looked at? You want another problem to graph? You want to look at any situation?
Can you do another one like this?
We can look at the circle again, or whatever you want.
Is the last one we did? Like the one-
Yes, very good. So let's look at 63. 63 on page 361. We have among all pairs of numbers whose difference is 16. How do I write two numbers whose difference is 16? Two numbers whose difference is 16. Very good. Find a pair whose product is as small as possible. So min product. Good. So I have the difference of two numbers equals 16. And now I would like to determine the product. In order to find the minimum, I have to find the function first. So how do I write the product of these two? Oops, I cannot write that yet. So the product is, I'll come back, the product of these two numbers is, very good. Again, I have two variables. I don't know how to handle two variables, but I have to use the information I'm given, and I prefer getting rid of y. If I want to get rid of y, I have to solve the given equation for y. In other words, I solve it in terms of x, and then I replace. So negative y equals negative x plus 16, and then what do I have to do to both sides to get y? Very good. So this is x minus 16. So I found an expression for y. And now I can write that the function p is a function of x only. So p of x is x multiplied by x minus 16. Because I replaced y by x minus 16. So then what is the final form of this product function? Yes? Very good. And remember, we have to have everything in descending order. Now I'm going to ask myself, okay, it's quadratic, but does it have a minimum? Because if it doesn't have a minimum, then I'm not on the right track to find the minimum product. So does it have a minimum? Yes, because the leading coefficient is, always remember x squared. X squared has a minimum and it has a positive leading coefficient. Good. How do I find the minimum then? I can only determine one thing that will give us the minimum, the vertex. Awesome. See, repetition, repetition, repetition. So negative from the formula. How much is b? Careful. Good. Over 2 times a, which is 2. Yes. So this is, oh, very good. So if x is 8, can anyone give us the second number? Negative 8. Now, I don't have to plug this in because I know one number is 8, the other number is negative 8, so I know the product. Negative 64. Now, let me caution you on something. Let's say we are looking at this function and the vertex is 8 comma negative 64. Because I've had that discussion with one of my students. He said, well, if you decrease 8, you're going to decrease the product even further. No. So this x is 8. If I go to 6, x equals 6. Look where the product is. It's not minimum. So there is only one point in the quadratic function that gives us the minimum. Only when x is 8. If you deviate from 8, the product of those numbers will be bigger, not minimum. So we'll finish with just the final sentence. The min product of two numbers that differ by 16 is negative 64. The numbers are x equals, y equals 8 and negative 8. Any questions?